So now we know that we can increase force for a contraction from a motor unit by stimulating that nerve or stimulating that muscle over and over and summating those twitches. So how do we increase contraction force beyond that? So if we look at contraction force, we need to look at the different motor units that are going to that muscle. So motor units, again, are the neuron and then all of its muscle cells that it innervates. So if we show the central nervous system here. So in the central nervous system, we're going to have cell bodies of neurons. So in the spinal cord or whatever, okay? So cell bodies, and then those axons are going to go out to muscle cells, right? So we don't know how many it's going to be. They vary, right? So let's just say that this one goes to 10 muscle cells, and let's say this one goes to, let's say 40 muscle cells. Let's say this one goes to 6 muscle cells. And let's say this one goes to 70 muscle cells. We know also about these motor units is that all the fibers within these motor units are the same. Okay, they're not like there's slow twitch fibers and fast twitch fibers within here. Okay, all the muscle cells are of the same type. So in a contraction, in order to get more contraction force, we can bring in, or the body can bring in or recruit more motor units. Okay, so the central nervous system basically controls who to fire and when. Okay, so the central nervous system controls who to fire and when. Okay, so we also know that each of these motor units can be stimulated more than once. So let's say this one's stimulated this many times. Let's say this one's stimulated even more. Let's say this one is a bigger one and doesn't stimulate that well. Let's say this one is here. Okay, so we could start, let's say the muscle is going to start here and stimulate this motor unit, and it is firing, and it may need some help, so then it will recruit, say, this motor unit, and maybe it needs more, so it will recruit this motor unit. Now when this motor unit gets tired, this one comes in and helps, and then this one gets tired and rests for a minute, and then this one turns back on, and so on and so on. Okay, so this is called recruitment. And it has a special name called asynchronous. Asynchronous recruitment. Asynchronous recruitment. And asynchronous recruitment is where motor units fire at different times. So they fire at different times. And this allows for resting of those motor units and reduces fatigue. Allows for resting of the motor units, and that reduces fatigue. Okay, so at a maximal force, then not as many of the motor units are going to be able to rest, right? So the more force and the more motor units are recruited on, then the more they have to be engaged, then the more powerful the contraction will be, but the less time it's going to last, and the more it's going to fatigue, because it's not going to be able to rest this one while this one goes, and so on, and that type of thing. Okay, but normally that's what's going on, and that is what's called recruitment. And asynchronous recruitment is what allows some of those motor units to be resting while others are engaging. So recruitment, the CNS controls who and when to fire, who to fire and when. It also controls the number of motor units that are firing. So CNS controls the number of motor units that are firing. So ultimately it controls the end resulting force. Okay. It controls the pace of stimulation. And remember, this is only in skeletal muscle. We're talking about skeletal muscle here, which is voluntary and controlled by the central nervous system. Okay? So this is how we get a really, really, really strong contraction. Don't forget, wave summation provides a strong, smooth contraction. But if we need more force, more power, more tension than that those motor units can provide just through stimulation, then we can just recruit more motor units.